Welcome everyone to this webinar on statistics, and today we will look at energy prices and energy efficiency indicators. And after having looked over the past few days at the different statistics sessions on the fundamentals of statistics, statistics by commodities, and yesterday on energy balances and CO2 emissions, this is another step further to having a complete picture of the energy statistics and data that you can use. This is the agenda for the Ghana session. So today we are looking at the statistics 4, and as from next week you will start the modeling sessions with Arnaud, where you will have 6 modeling sessions in total, followed by the SDG 7.1 access to clean cooking and electricity session, and the last session will be on May 18th. Before we start with the technical part, let us quickly look at some of the housekeeping rules. So the whole session is in virtual and is being recorded, and you can access all the videos on YouTube after the session. If you have any urgent clarification, you can use the reaction button and raise your hand, and we will give you the floor to ask your question. But if you have other questions related to the presentations, you can use the Q&A box at any time during the session, and we will answer all your questions live after the presentation or during the session itself. If you have any further questions, you can email me, Arnaud, or you can send your question also to the Africa program mailbox. So before we start with the presentation, let us do quickly some interactive questions on energy prices. I'm going to share my screen now. So please connect yourself to www.menti.com and use the code 974604 and 75. The first question is, what are the different components in the end user price paid by the consumer for energy commodities such as electricity and natural gas? So what makes up for the price paid by consumers for electricity and natural gas? So think about it. When you pay for electricity and natural gas, what are you paying for? What are the different components? I'll give you a few seconds to reply. So for the moment, no one has been replying. So I'm going to give you some hints. So think about, first, there are the different costs for producing the fuel, the distribution costs. So there's this ex-tax price, and then you have different taxes that are added. There are excise taxes such as CO2 tax, environmental tax, and there's also the value-added tax that are added on your consumption, depending on your consumption. So all these make up for the price paid by consumers. So let's move to the, so indeed, there have been some answers arriving for the first question, which is some people put capacity charge, operations, maintenance, fix, OM, fuel cost. Yes. So very good. Next question. Are you aware of price data tracking in your country? So in your country, are you aware of price data tracking? Yes or no? So we have a few participants saying yes. and one that said no. So this is good. So now we have 3 that says that they know that there is some prices data collection happening. I see in the Q&A box that someone said no, but I think now the sound is good. So I don't know if it's on your side, Lamin Maron, the issue. So very good. So we have more people that are aware of prices data collection. So next question is, do prices data feed the policy work in your country? So do prices data feed the policy work in your country? Yes or no? So very good. We have 2 participants that said yes, which is good. One that does not know. 2. So good. We have more people that think that prices data feed policy work in their country. So another question, who is responsible for the price data collection in your country? So do you know of ministry, statistics office that are responsible for collecting prices data in your country? So here you can write down if you know of those entities that do this work. And especially we are interested in knowing because we will be having bilateral meetings on energy prices. So we are really interested in developing and improving our data collection on prices at the IEA and collaborate with the different entities in your country. So yes, so there's PERC, Energy Commission, Statistical Service, ECG, Energy Commission again, Regulatory Service Agency, NPA, so excellent. So I think that was another last question. So what are the challenges for prices data collection in your country? So do you face challenges for those who work on prices data collection? Can you let us know what are the challenges that you face in your country, or even for those that don't collect, if you're aware of challenges for collecting such data? So please write it down. So consistency, yes. Timely submission, indeed. Timeliness, accuracy. It's also costly. There's also the human, the resources needed to collect those kind of, yes, cost. Time, yes, you need resources also to collect data and process the data. So excellent. So respect for contracts, data validation, data accuracy, yes, all these are challenges. Very good. So now let's move to the presentation. So we have done the Menti questions. So this is the agenda. We will start with energy prices. We will look at why energy prices are important and at the different statistical concepts for end user prices and also the comparability. And then for energy prices, we will do a small exercise together. After prices, we will look at energy efficiency indicators, where we will look at the different concepts, the importance of collecting such data, etc. So let's get started now.
Why are energy prices important? Energy prices are important because they affect our lives as consumers and the competitiveness of a private enterprise and therefore the economy of our country. End users' energy prices are influenced by price movements in the raw commodity markets. For instance, crude oil spot price market. The international spot price market is in turn affected to major events such as economic developments or even natural disasters. In the graph, we can see the step price decreases caused by global financial crisis in 2008-2009 and the oversupply in the market in year 2014. More recently, we can see the effect of the COVID pandemic on the market with the reduction of the price linked to the reduction of the consumption. But the cost of the raw material and the international markets doesn't capture the full story. In fact, the end-use price paid by consumers is subject to taxation that might represent the major share of the final prices. Why do governments tax energy commodities? The taxation of energy products may pursue different objectives. The first objective could be public revenue generation. In the short-medium term, energy demand is relatively inelastic, making energy products good targets for revenue generation. Another objective could be internalizing the environmental and health costs associated to emissions or other types of pollution. The third objective of taxation is to drive the change. High taxation on the most polluting fossil fuels can help shift consumption towards a less polluting and therefore less taxed energy commodities. Tracking energy prices is important also because they represent a significant share of our daily lives expenditures. For households, for example, the direct expenditure on energy might represent up to 17% of the household spending. The same can be applied to industry. Industry competitiveness is greatly affected by energy costs. This is true especially for energy-intensive processes, such as aluminum production, for which energy costs can represent around 40% of the production costs. For all those reasons, it is very important to track energy prices in our country and to have an international methodology that allows us to compare prices across the world. Here at the IEA, we track energy prices across the world in the Energy Prices database. The map on this slide shows gasoline prices across the world drawn from this database. An accurate database is the basis for conducting accurate and robust analysis on the energy scenario and for assessing the competitiveness of a country. Such data also allows for evidence-based policymaking and energy transition planning. Robust data allow to draw comparison to regional differences. For example, thanks to this dataset, we can say that consumers in Africa pays on average the gasoline 30% less than the average of the world, and 50% less than European consumers. This dataset enables also further analysis such as the one showed with this graph. This graph illustrates gasoline price levels across countries based on GDP per capita, and it is taken from the IEA commentary on gasoline prices across the world. In this graph, we see that price levels are, in most countries, linked to the economic conjuncture of the country itself. Based on GDP per capita, we can identify 4 clusters of countries. Many developing countries fall in the cluster at the bottom left of the graph, since their governments often keep prices low to increase energy access. Please feel free to refer to the IEA commentary for further information and analysis on this topic. As mentioned before, it is important to have a common methodology for tracking energy price. This allows to have a solid international benchmark and comparable data. So let's now turn to the IEA methodology, which provides for such a common methodology, and which has been adopted and used by other international organizations. End-use energy price is the sum of 2 subcomponents: ex-tax price and taxation, which is the sum of value-added tax and excise taxation. Having information on these components allows us to have a more solid understanding of the situation in the country and to draw policy implication and guide policy making. The ex-tax price includes all the costs incurred for producing the final product throughout the supply chain, except taxes. This includes the cost of raw materials, manufacturing costs, distribution costs, and profit. The excise taxation, instead, is generally levied on a volume basis and excludes the VAT component. This taxation might have different policy objectives and includes CO2 taxes, other environmental taxes, motor fuel taxes, emergency stock fees, and any other taxation applied to the commodity. And the last component is the VAT taxation. VAT taxation is a consumption tax on value added, and it is generally applied to the sum of the ex-tax price and excise taxation. As of 2020, over 170 countries had VAT or an equivalent taxes in place. To better understand each of those price components and how these can affect the end user price, let's have a look at a simple example of 2 hypothetical countries, A and B. Country A and country B have 2 different ex-tax prices for gasoline. This may depend on the different relative scarcity of the oil resources in the 2 countries, or on different refinery and distribution costs. The government in country A decided to implement a lower excise taxation compared to country B, maybe to compensate the high ex-tax price. Country A has also a lower VAT rate compared to country B. So overall, the total taxation on gasoline in country A is lower than in country B. If we apply the VAT rate to the sum of the ex-tax and excise taxation, we obtain the VAT amount, which is summed to the excise tax, gives us the total taxation for fuel. As mentioned, the total taxation in country A is lower than the one in country B, and this makes the end user price lower despite the higher costs along the supply chain. Now let's delve into the methodology to calculate representative end user prices. What is the representative price for a country? Energy prices may vary across regions and provinces of the same country. For example, this map shows more expensive gasoline prices in the western parts of the United States compared to the prices in the southeastern states. Again, using an example may help better understand. Let's consider a country, which we will call Statisland, with two provinces, Eastern Statisland and Western Statisland. In Eastern Statisland, the price of diesel is $0.5 per liter, while in Western Statisland, gasoline is more expensive, at $1 per liter. Diesel consumption is 500 kiloliters in the Eastern Statisland and just 100 kiloliters in the Western Statisland. If we calculated the simple arithmetical average of the two prices, we would have a $0.75 per liter. Is this a representative price? The answer is no, because as we can see from the input data, consumption is 5 times higher in the region with the lower price. Therefore, if we were to compute the simple average, we would not take into account this difference in consumption. In order to calculate a representative price, we need to weigh prices by consumption. If we take consumption into account, we obtain $0.558 per liter, which is the representative price for the country. When calculating a representative price, another important concept is the difference between prices and tariffs. In the data collection undertaken for our data tracking, we are interested in the prices, namely the average rate per unit actually paid by the consumers no matter what is the price structure for the commodity in the country. Again, let's take a look at an example, this time on electricity prices. We all know that in general the electricity bill has two components, fixed charges and the variable charges. The fixed charges pay for the connection to the grid and it is not linked to the energy consumption. The variable component, on the contrary, is based on the quantity of energy consumed each month. In this case, to calculate the representative end user price for a user, we need to calculate the total electricity bill and divide it by the energy consumed. The total bill is the sum of fixed charges, 10 euros in this case, and the variable charges, which are 0.1 euros per kilowatt hour times 150 kilowatt hours. The total paid is 25 euros. The total now should be divided by the energy consumed, which is again 150 kilowatt hour. This gives the representative price for this consumer, which is 0.17 euros per kilowatt hour. To conclude, energy is an important component of our lives and for the economic development of our countries. And energy is a significant expenditure for our budgets. A solid energy price tracking system, one that allows having comprehensive and comparable data, is a key requirement for evidence-based policy making and policy choices to increase the energy affordability and foster a green and just transition. IEA stands ready to advise and support countries along this path. Please contact us to receive more information on how IEA can support your country develop more solid energy price tracking systems that will support sound and effective policy choices. Thanks.
So I hope that this presentation on energy prices has been useful to you. And I'm very happy to be joined by Domenico Latanzio, who is an expert on energy prices and taxes at the IEA. And we stand ready to take your questions. So hi, Domenico.
Hi all, nice to have you here.
So please send us your questions in the Q&A box regarding prices, or if you have any questions on the presentation, if there has been something that you have not understood well, and Domenico can give more explanation, please. In the meantime, Domenico, are you collecting prices for Ghana in our database?
Yes, we do have some prices for Ghana in our database. So happy to engage with you and also to double check and to open a discussion on it. If you have more data or if we can track better the data for your country.
That would be great. And as I said earlier, we will have bilaterals on energy prices organized after the end of the training. And we are really looking for participants who work on the subject with whom we could exchange and make sure that we include you in the discussion. So if you work on prices, or if you know on the subject and all, please contact us and we'll make sure that we include you in the discussions. We are really looking at improving our data collection and add more to the database. So maybe I don't know exactly what level of data we have, but indeed increasing the coverage would be great, and also making sure that we are capturing all the information. Please send us questions and take advantage that we have Domenico with us in case you have any questions. I think there's one that arrived. So what role does exchange rates play in fuel price calculations? You want to reply to this one, Domenico?
Yes, sure. This is an important question. As you have seen, there are different components in the energy price. So each of which is affected in a different way by the exchange rates. For example, if we think about gasoline, we are talking about a global market for crude oil. So it's a spot market traded in dollars. And so this affects the part of the price, which is the ex-tax price. And of course, whenever there is a movement there in the spot market, this movement is based on dollars. Then you need to exchange this movement by your exchange rates. That is might be fixed compared to dollars or like might change. So it affects a lot the ex-tax price because of the global market. It affects less the excise taxation and the taxation because it's the specificity is specific of the country, and then of course it affects comparability whenever you are comparing prices. For example, the typical example is whenever the gasoline price is fixed by the country, and then if you are comparing the price in US dollars, you won't see that price was fixed because the exchange rates changes from day to day. So we need to take this with a pinch of salt every time and to check what happened in the country for the prices and also what happened to the currency. So the two metrics always are important to have a look at.
Thanks, Domenico. Please send us questions more questions if you have. So there's one that arrived. Does the IEA compile database of price structure of petroleum products across various countries? If yes, is it accessible?
I might have lost you. So that does the IEA tracks?
Yeah, does the IEA compile a database of price structure of petroleum products across various countries? If yes, is it accessible?
Yes, so we have two main publications, one for global prices and the other one for OECD prices. The two publications are very similar, but like with a common methodology, but they have different data availability. For OECD country only, we have what we call the taxation breakdown with the three components that you have seen in the presentation. So ex-tax price, excise, VAT, and total price. And for that, those you can access those data. It's a database called Energy Prices and Taxes for OECD countries, and you have all the details there. So please get in contact with us. We are happy to show you what we have.
And
for
this
the global,
one, is it free?
No, this is for subscribers, but of course, like for data providers, we can find a solution to let you access what you need. And for the global database, which is the world energy prices, we have only the final price. So we don't have the price structure for all the countries, because to have this price structure, you need to really to have a contact in the country and to have really the policy under control and to know all the components. This is not easy. For OECD is possible because we have a questionnaire that we issue every 3 months, every quarter, and then we have country contacts in the country itself compiling those data for us, and that's very value added. Of course, we have also some experiences with non-members compiling this questionnaire, and if any of you is interested in following this path, we have good examples of countries that were not OECD that joined this data tracking for both their internal use, and then they share those information with us. So please, we're really happy to open a conversation on that.
Thanks, Domenico. There's another question. In terms of setting tariffs, which of the following options will be cost effective for the end user? The first option is tariff categorized into capacity, charge, and energy, or tariff which gas being set based on energy where the capacity is indexed to energy. So in terms of setting tariffs, you got the question?
Yeah, so I mean, the setting the tariff is always something very difficult, and we are also collaborating with different countries in the world about that and how to have the most effective policy in place. This is always a challenge for different reasons, because the market is changing, and every time the situation is changing, but the solution, there is no single solution in our opinion, in my opinion. It depends really on the structure of the country, what are your challenges and what you want to do. So for example, the first things that needs to be guaranteed, and then this is a priority for any country, is accessibility to the energy. So you need to develop a policy which let all the users access the energy. So maybe having exemptions for the poor part of the population, and then this about how to split the charges on the fixed side or on the variable side. It's a big ongoing conversation, also because of the renewables, for example, striking into the market. And then, for example, if you have solar PV in your house, and then like in Europe there are a lot of those discussions. Should you pay less because you have the solar PV on your house, or should you pay more because you are stressing the grid because you are also producing? So there is no short answer. It really depends on the first objectives of your countries and second the structure of your country.
Thanks, Domenico. There's a question about sharing the slides with the participants of each presentation. So normally, before the training started, Arnaud had sent an email to all the participants with a link to a Google Drive where we had put all the presentations in advance. And you also received the handbook with the questions and answers, and also the Excel file to do the exercises. So if you have not received that email, please write to me or to Arnaud and we will share it again with you. But normally all the participants should have received that email with access to all the presentations. And there's another question for you, Domenico. Do you have samples of petroleum products prices indices for countries?
Can you hear me?
Yeah.
Okay. Yes. We we have the final prices from them. From there you can also draw indices. So we have the final price. We usually use the final price as the index for the specific product, because we have selected a representative product for each consumer. The database is structured in a way that you have the products. So, for example, gasoline, diesel, electricity, natural gas, and then the users, which are commercial, industry, households. So you have already the category that you're looking at with the prices associated to this category. So you can really compare this category in your country with another category in other countries.
Thank you. So please, if you have more questions, we have a few more minutes before moving to the exercise session. So don't hesitate.
So for Ghana, we take data from the National Petroleum Authority, and this is our source. So if in the room there is anybody from this authority, and please get in contact with us, or and please, we will make sure that you will be included in the participants to the meeting on prices.
Yes, of course. No more questions from participants? No. So there's a question. Do you pick the price data from the NPA website?
Yes. Yeah, the short answer is yes. I don't know if the colleague Tijani Shaibu is from the authority. We can get into detail on what we are looking at the prices. But yes, we usually use official sources in the country whenever we don't have a contact. And then right now we are covering around 140 countries in the world. So it's really a global database, and all of them, I mean, let's say half of them are built on contacts, and the other half are data retrieved from individual publication from individual countries.
Thank you. So if you have information to share with Domenico, you can write directly to him at prices@iea.org. So that's the email to access to contact Domenico and the prices team directly. Or you can also write to me, and I will make sure that the message is forwarded to Domenico. And as he mentioned, we are really looking forward to collaborate more with with the people in Ghana who work on prices and improve our database, and also help you if you need access to the data. It will be a mutual exchange. So thank you. I don't see any more questions, so maybe we will move to the exercise part now. So thanks a lot, Domenico, for answering all the questions. And yes, so let's move to the
Thank you, Zakia. Thank you to all the participants for the attention. And again, please get in contact if in need and if you need to access the database.
Yes, do not hesitate
Have a good
to reach out.
exercise session.
Thanks, Domenico. Bye.
Bye-bye.
So that was the exercise on energy prices. So you had a country A, data for country A. So for households, for taxes, for industrial consumers, and also for power plant surveys. And the first question was, calculate the average natural gas price for household, industry, and electric utilities. And here it tells us to fill only the highlighted yellow cells for household, industry, and electricity plants. And here you have to use the information provided on the left side. So first, let's look at taxes, which is the easiest. So here we know that we have a value added tax at 20% for 2019. And so for household, you already know the percentage value added. So here in G13, you can already put 20%. And you know that industries and electricity power plants, they don't pay VAT. So here you will put 0 in the column R11 and R18. So for VAT, we are done. Then excise tax. It says that excise tax, it's at 31.9 euro per megawatt hour gross calorific value. And here we know that households do not pay excise tax. So here you will put 0. And industries and electricity plants, they do pay excise tax. So here you can put that information in the cell Q11 and Q18. So for excise tax, we are done. Now let's go back to household table here and try to fill everything. So for household, we are given information on the average spending for heating and cooking by gas in euro, which is 3,380 euro. And you also know the average consumption of natural gas in megawatt hour, GCV, which is 2.4. So here you can calculate your total price by taking your average spending and dividing by your average consumption, and you will get the price paid in euro per megawatt hour. And here, that's what we do. And you get 1,360. So that's the total price paid in euro per megawatt hour. So you know that, you know the total price, you know the VAT percentage. So we need to back calculate the ex-tax price using that information. So here you take your total price, you divide it by your 1 plus 20% because we are back calculating, and you get your amount of ex-tax price. And here you know that the VAT amount, it's 20% of that, of the ex-tax price. So you get 227 euro. So your total tax is equal to your VAT amount because there's no excise tax. So here we have been able to fill the whole household 2019 price information. Let's now move to the industry. So for industry, we have the revenue information, and it's precise here. It excludes excise tax. And here it says 49.8 billion euro. And you also have the information about the quantity of gas sold to industrial consumers, which is 55,189 in gigawatt hour. So here, given that it's precise excluding excise tax, here we can calculate the amount of ex-tax price for industry. And here you take your revenue and you divide it by your quantity of gas sold. But here, note the difference in units here. Here you have billion euros and here you have gigawatt. And here we are looking for information in euro per megawatt. So here you adjust the unit by multiplying by 10 to the power of 6. So you end up with 902 euro per megawatt hour GCV. So for industry, we have the ex-tax price, we have the excise tax. We know that VAT is 0%, so the VAT amount is 0. You know the total tax is equal to the excise tax, and so your total price is your ex-tax price plus the total tax amount, which gives you 933 euro per megawatt hour. Now let's move to electricity power plants generation. So here, what information do we have? It says we know the average purchase price of natural gas in 2015. Again, here it's excluding tax. So here it's 735 euro per megawatt hour. But here it's in NCV, it's in net calorific values. And we know that the ratio when you move from gross to net, it's 0.9%. So here, what will we do? For the ex-tax price, it will be, you will take your amount, the average price, because you already know it, but given that it's in NCV and you want it in GCV, here you will multiply by 0.9. And you multiply here because here your the megawatt hour NCV, it's in the denominator. So here you multiply. So we know the ex-tax price. We know the excise tax. Again, you know the total tax is equal to excise tax, and your total price is the sum of your ex-tax price plus the total tax. So for question 1, we have answered everything. Now let's look at question 2. Question 2 is calculate the growth rate of natural gas prices between 2010 and 2019. So here, to what it's asking, it's in the red cells here, we will have to fill for question 2. So the growth rate from 2010 to 2019, you take your 2019 value, you divide it by your 2010 value, and it's -1. So you get 18% growth rate. So here we see that prices have increased by 18% for household. Can you say that prices increased since 2010? If not, how could you modify the prices to have a better comparison in time? So here we cannot, even though we have an 18% increase here, it's just a nominal price, a growth in nominal price, and it doesn't really reflect the reality. So here the comparison, it does not take into account the inflation, so a deflator, and in this case, a consumer price index. So because we are looking at household, we look at the consumer price index. And so we should apply a consumer price index to look at the real price evolution. So here, what will we do? We will recalculate the price adjusted to the CPI. So here, what we do is that we take the normal price, the nominal price here for 2010, and we multiply it, we divide it by the CPI. So here we get, so here we get the adjusted price, so the price in real terms for 2010, and same for 2019. We take the price and we divide it by the 2019 value. And if we recalculate the growth rate now, we see that it's decreasing by 5%. And this is quite different from the nominal price increase, which was 18%. So we can see that when we correct the prices, the natural gas price is actually declining. So that was the small exercise on prices. I really recommend you all to try to work on it by yourself and make use of the presentation guidelines to better understand a bit how the different pieces fits together. You can also send me questions by email on the exercise, and I will be happy to reply to you on this. So now let's go back to the presentation. So we have done prices, and now let's move to the energy prices indicators. So energy efficiency indicators, I'm sorry. So here we will look at why is it important to develop energy efficiency indicators, and we will also see what information is available from the energy balances that you can use to calculate those indicators, and also what further data are needed to track energy efficiency, because just energy balances data is not enough. We will also see together how to collect those data, and then we will end with an exercise session. So let's get started here.
So, why energy efficiency is important, and why do we need energy efficiency indicators? Usually, when we think about energy efficiency and why it's necessary, we'll think about the reduction in energy consumption. However, there are many other benefits from energy efficiency. Here we can see what we call the energy efficiency flower, representing multiple benefits from energy efficiency improvement. Those benefits can be economic, social, environmental. For example, by increasing employment, increasing energy security, or by reducing harmful emissions. This is why many countries have set energy efficiency targets, and this is why it's important to have end-use data to track the progress of energy efficiency policies and to be able to set the correct target for those policies. Here we can see policy design examples. We're also benchmarking exercises, which are an important application of this kind of data. However, there is still a very high portion of energy consumption that is not covered by energy efficiency policies, and this represents a large potential for action. Only 35% of the global energy consumption is subject to mandatory efficiency standards. And it's estimated that in Africa, only 2% of energy demand is covered by energy efficiency policies. This is why it's very important to have detailed data in order to be able to study energy efficiency trends in depth, to know the priority areas and where we stand, to set the targets, and to track and monitor the actions. But now, let's see what kind of data are already available from the energy balances. Energy balances give a very useful piece of information, and combined with some macroeconomic data allows to calculate aggregated indicators, like for example the energy intensity. However, there are limitations in terms of the disaggregation of the data. For example, in an energy balance, the residential and the services sector are represented as total, while in order to study energy efficiency, we would need a further disaggregation by end use, for example, space cooling and space heating. One of the possible starting points to identify priorities in the breakdown of final energy consumption by sector. Usually this information can be easily extracted from the energy balance of a country. So, for example, in this case, we can identify that the residential sector is the most consuming, so it's likely to be considered a priority sector for energy savings. However, we need more detailed data to better assess this, like for example, the consumption by end use, such as cooking, water heating, or space cooling, and the related activity data, like number of occupied dwellings or surface. Not having proper data could lead to wrong policy decisions and actions. Let's see now an example of widely used, the energy intensity. We can see a figure illustrating the energy intensity trends for different regions since 2000 to 2018. Energy intensity is commonly used as a proxy for energy efficiency. However, the indicator is too high level and includes different factors, such as the structure of an economy or the activity, besides real efficiency. So in order to study efficiency, we need more detailed data. Let's see another example where we study the residential sector trends, starting by using the most aggregated data to using the most detailed one. If we analyze the residential consumption over 20 years, shown in the graph in the blue line, we see that there has been an increase as a whole, plus 15%. However, we can see that the consumption per capita, the red line, is at the same levels at the end of the period, more or less. If we go to the more detailed data indicators, for example, the consumption of energy for space heating divided by occupied dwellings or by floor area, we can see a dramatic reduction over the analyzed period. So this means that even if residential energy consumption increased and residential consumption per capita did more or less remain stable, important efficiency improvements are witnessed in space heating. The residential per capita indicator did not show any change even with the big efficiency improvements in some end uses, probably because of the increased use of new appliances, such as smartphones, computers, tablets. So all in all, it is essential to choose the most appropriate indicator depending on what do we want to observe. If we just look at the total residential energy consumption, we would observe that the total final energy consumption has increased by 15%. However, this does not mean that we are less efficient now. For instance, the residential space heating energy consumption per floor area has decreased 35%. So it's really important to choose the proper indicator depending on the message we want to give and what we want to observe. So what drives energy intensity then? The efficiency progress is one of the drivers. For example, more efficient industrial processes will contribute to a lower overall intensity. But there are also other factors like the increase of the activity, for example, the increase of population, more houses, more cars, or the structural change of an economy, for example, a country switching from the industry to the service sector, which is less energy intensive, that also affect the energy intensity. So it's really important to differentiate which improvements come from improvement in energy efficiency to track the impact of energy efficiency policies. Here, for example, we can see how energy efficiency helps to decrease the overall energy consumption, while the increase in the activity contributes to the opposite. So, what additional data are needed in order to study energy efficiency? As we have seen from the energy balances information, we can create some energy indicators such as the total final consumption per population. However, those indicators are not specific enough to monitor energy efficiency. In order to study energy efficiency and obtain energy efficiency indicators, we need end-use data or even more disaggregated data. However, the greater the disaggregation, the more data are needed, and usually this also comes with higher cost. Collecting data is costly, but enables a better design, monitoring, and evaluation of policy. Not having proper data could lead, as we said before, to incorrect decisions and actions, and as a consequence to even higher costs. Also, in order to develop indicators, apart from energy consumption data, it is essential to also collect activity data. The activity data are sector specific. It could be a physical production of a certain commodity like cement or steel, floor area, or the distance driven by a vehicle. Combining energy consumption and activity data, we can obtain efficiency indicators that explain how much energy is needed to provide a certain service. For instance, how much energy is needed to produce a ton of steel. Let's now see which data we can collect for every sector. And let's start with the residential sector. In order to calculate energy efficiency indicators for the residential sector, the IEA recommends collecting energy consumption data by end use. So, for example, space heating and cooling, water heating, cooking, lighting, as well as energy consumption of different appliances, such as dishwashers or televisions. It's also important to collect data on heating degree days and cooling degree days in order to be able to correct space heating and space cooling energy consumption for the year-to-year variation of the temperature. In other words, when we analyze energy efficiency indicators for space heating and space cooling, we want to observe change in the energy consumption resulting from the energy efficiency improvements and not from the climate effect over this consumption. If the winter is harder, then it's very likely that people are going to consume more energy for space heating, for example. And we want to avoid this effect. Regarding the activity data for the residential sector, we could collect information on the number of dwellings, particularly occupied dwellings, residential floor area, as well as stocks of different types of appliances. We should also pay attention to the activity data we use for our indicators. For example, if we use total dwellings, we will also account for abandoned dwellings and secondary residences. Therefore, in order to avoid counting in efficiency empty buildings which does not consume, we should exclude vacation homes and unoccupied dwellings. And so this way we keep the same boundaries between the energy consumption and the activities related to this energy consumption. Let's now have a look at what we can do in terms of data collection for the service sector. For energy, we can also collect data by end use. So, for example, space heating and cooling, lighting, other energy uses in service buildings, and also non-building energy use, for example, street lighting. We can also collect electricity and other fuel consumption data and floor area by IC categories instead of by end use. But it's also good to do for both end use and IC categories. And the most relevant activity data would be the value added, the floor area, or the number of employees, for example. The next sector is industry, and for energy, in the IEA we collect data for 19 major IC subsectors, and when it's possible we encourage more detailed data collections. For example, energy consumed to produce aluminium or cement, since this data collection allows for physical indicators that are more detailed than the major IC categories. And when it comes to activity data, we focus on the value added created by a given subsector. But for certain energy intensive and homogeneous industries like paper and iron and steel, we can collect also the data on the physical production, such as the tons of steel produced. And finally, the transport sector. It might seem a little bit more complicated than the other sectors because here we differentiate between transport segments and modes. So segments include passenger and freight transport, while modes refer to road, rail, air, and water. Regarding the activity for the transport sector, we want to observe how much and how far we can move. So for instance, how many passengers or tons of goods we can move and how far. To measure this, we use vehicle stocks, vehicle kilometers, passenger kilometers, ton kilometers, and we calculate passenger kilometers and ton kilometers as the total distance traveled by all the vehicle stocks that we are analyzing, multiplied by the occupancy for passenger transport or by the load factor in case of the freight transport. But how can we collect all this data we are mentioning? So in 2009, the IEA members countries agreed on the new energy efficiency indicators data collection. Thanks to the cooperation with international experts, an Excel template was developed, and you can find this template already in the IEA website. And with this template, the IEA collects both energy and activity data for all the four sectors presented: residential, services, industry, and transport. In December, we published the energy efficiency indicators database and a report called Energy Efficiency Indicators Highlight, where we include all the countries that collaborate with us, not only members. We are open to collaborate with any country that would like to do so. And this report, of course, is also available online free of charge. And on top of that, the IEA has also cooperated with AFREC to develop a questionnaire for energy efficiency, particularly for the residential sector. So on the country level, the IEA differentiates four main data collection methods. And firstly, before starting any new data collection, it's good to make sure that this data is not already collected. So for instance, if you need some activity data for transport sector, it is possible that the Ministry of Transport is already has this data. So it's very important to map where all the data that I need might be located. If you are sure that these data are not available, you can start your own data collection by launching, for example, a new survey, or you can even decide for a less expensive options, which could be expanding an already existing survey. For example, adding some transport questions or household surveys. Another method is metering and measuring that is relatively costly but really effective if you want to measure efficiency of some specific equipment. And here we can also find, for example, smart meters, which are more and more used nowadays. And we also have modeling, which is the last of the four methods, and it can be complementary to surveys and metering or used standalone. For instance, by using activity data and total energy consumption data from the energy balances as input to estimate energy consumption by end use, for example. The IEA has developed two manuals. The first one is the Fundamentals on Statistics and provides guidance on how to collect data and how to develop those efficiency indicators. And it includes also a compilation of existing practices of data collection from across the world. And the second one is the Essentials for Policymakers, which advise on how to develop those indicators as well, and particularly how to interpret the energy efficiency indicators. Both manuals are available on the IEA website in English, Spanish, Russian, Chinese, and also French. Before starting any data collection, it's always useful to have a look at what other countries have done. For this purpose, the IEA developed the country practice database, which is a very useful resource to learn from each other. It's a very powerful tool worth consulting before undertaking any new data collection, because it allows seeing what other countries did and to take an advantage of their experience. For example, if you are planning to develop a new data collection, such as a new household survey, for example, you can check what other countries have done and even the details of that survey, the results, and even the questionnaire of that survey. And also, if you have a country practice that you wish to share, please contact us so we can make it available for others and others can benefit from your expertise. I would like to conclude with some key messages. First of all, detailed energy and activity end-use data are crucial for well-informed and effective policies. These data are essential for identifying priority sectors and understanding energy efficiency trends and monitoring policy effectiveness. Therefore, it's extremely important to raise people's awareness of the detailed data needs and underline benefits of country-specific data collection and analysis. It's also important to benefit from the experience of other countries and organizations, as well as contributing to this. So we invite all countries that want to start collaborating with us on end-use data and efficiency indicators to reach out, and we can discuss in more detail the potential collaborations we could develop with you.
So I hope that this presentation on energy efficiency indicators has been helpful to you to better understand the importance of collecting energy efficiency indicators, and also gave you some guidelines of what you could do. And so now I'm joined by my colleagues who work on energy efficiency indicators data collection at the IEA. And I'm happy to welcome Young-Yu Park, who will help with answering any questions you might have. So please, if you have any questions, write them in the question and answer box, and we will answer them live. So hi, Young-Yu.
Hello, Zakia. Thank you for your introduction. Yes, very nice to meet you, and we are very welcome to receive your questions in regard of the top energy efficiency indicators topic.
Yes, please take advantage that we have an expert on energy efficiency indicators data collection with us to send us your questions. And even please tell us if you are aware of such data being collected in your country. We are very interested in knowing about how this kind of data collection is being developed. Is there something already happening, or are you planning to start doing it if you have not yet started doing it? Or what kind of data you're collecting? We are very interested in learning from you about this. Also note that we will be organizing bilateral meetings on energy efficiency indicators after the training. So please, if you work on the topic and would be interested in participating in the meeting, reach out to us, and we will make sure that we put you in the list and make sure that you are part of this work. So please, if you have any questions, let us know. we have some time before going to the exercise session, so please take advantage. And so I think we have a first one in the box. There's a first question about what factors account for the 2% of energy efficiency for Africa. What factors account for the 2% energy efficiency in Africa? I think this was in the slide. So maybe in general, we can, the question would be, why is energy efficiency so low in Africa? So maybe if you want to elaborate a bit on this, Yongyu. I can try to see if I find the slide as well.
Yes, I think so far the energy efficiency has been highlighted in the most important topic around the world. So it is now the gain more the increasing more the
Trying to see if I can find where the 2% was.
Yes, please check here because or the quam.
Yes, it's this one. I will share my screen. So the participant is referring to this slide, which the 2% was the amount of energy demand that is covered by energy efficiency policies.
Okay, so yeah, regarding this, the this amount to 2% means the total energy considered on the prioritized and covered by the energy efficiency policies. So it means we still have the 98% of the possibility to improve in the future. Yeah, so that's why we need to encourage our countries to the focus and the encourage to start the collection on energy efficiency to track the energy efficiency policies.
Yes, indeed. In Africa, there's a lot of potential and we can see that a lot of the energy demand, I mean, almost all of the energy demand is not yet covered by energy efficiency policies. That it's why it's really important to start working more on the subject and develop energy efficiency indicators that would help policymakers make policies related to the sector.
And there's a second question from Ivan. To answer your question, I think you can prioritize some sector depending on your priority. For example, from the energy balances, we can see which sector is most energy consuming inside the country. So in 2019, until we received data, I saw the 40% of energy consumption was on the residential sector from Ghana, and also the 34% of the energy consumption was on transport. So maybe you can prioritize more on this country, or if you have any data available from the other sector, for example, industry by industry subsectors, then also you can start to build and make energy policies regarding the sector. So it's quite it's not the same for every country. It's really up to your priority and your sector where you are focusing on.
Thanks, Yu. So please, if you have more questions, let us know. No more questions?
Maybe I can ask a question to the audience. I don't know if they will be able to respond, but maybe regarding the 2% untapped potential of efficiency in Africa, I was wondering what would be the situation in Ghana if participants have an idea on the potential that is covered or not by efficiency policies in the country.
Yes, that would be very interesting to know. So if anyone knows the answer or would like to comment on this, please raise your hand and I can give you the floor to speak. No comment?
And what about the energy efficiency indicators data collection? Is it advanced in Ghana? Do you have household surveys? Would be interesting also to know a little bit the status in the country if you are working on it at the moment. If you see, where do you see the next priorities to be? Would be useful for us to understand.
You can also write your comments in the Q&A box for us or in the chat box for the panelists if you don't want to take the floor and talk live. But please do write, do let us know what is being done in Ghana on the topic. No comments? Or if you have other questions. So there's a question, there's a comment that says colleagues from the Energy Commission or the ministry should be able to respond to this, indeed.
Yes, I think we will have the chance to explore that in more detail later on. I was just wondering about the participants' opinion.
Yes, we'll make sure that when we do the bilateral meetings that people from the Energy Commission and the ministry are invited. Well, I think if there's no question on the topic, we'll move on with the exercise session. So thanks a lot. Oh, there's a question. So does the IEA have a database document of possible energy efficiency measures, especially for developing countries? So
yes, we have the two special the manuals for the energy efficiency indicators. Actually, that was introduced during the presentation. So that we have the database, naming country practice database, which is showing how other countries was developed their own end use data collection. Yes, this is it is. Also, I can share the link for this database so you can have a look. I will share in the chat. Yes, so this database is quite useful for the countries which just start to think how they will collect the end use data collection. So they have the 4 different sectors and different methodologies. For example, administrative sources, measuring, modeling, survey. So you can choose the sector and methodology, or just to choose sector or just a search. Then you will see the how other countries was done before. Also, we are very happy to receive your own experience in case you have any experience on the data collection. So yeah, feel free to contact us. Also, we have the manuals in these links. I only sent the link. The first one is the more related on the data collection, naming the fundamentals on statistics. So this describes which the energy and the use, which level of end use and which activity data is more useful to develop the energy efficiency indicators to track energy efficiency policies. And also the other one is essential for policy making. So this shows how to understand and interpret the developed indicators, and also it describes how to see the efficiency effect from the energy efficiency indicators by using the decomposition methodologies. So feel free to have a look. There are all free resources available in the IEA website, and please feel free to contact us in case you have any questions.
Yes, thank you, Yungyu. And indeed, if you have any questions or you would like us to, more information on the database or the different manuals, the 2 manuals that we have, you can have those information on the website, but you can also reach out to me or to the energy efficiency teams. Maybe you can put the email for the energy indicators database, and then people can also reach out to you directly, Yungyu. But
yes,
maybe I could also add something here. So Jungyu presented a useful resource in terms of data collection, which we know data is very much needed if we want to design the right policies to improve energy efficiency and to monitor efficiency. But I think the participant referred to measures. So I understand probably the question was more about policies to be implemented in Africa. And in fact, the IEA does also have a policy database in case you are interested to have a look. So you can select by region. And I can also share the link, in fact, where you can see the examples of energy efficiency policies implemented in Africa and also by country, if you're looking for other examples.
yes, I think you're referring to the PAMS database. Yeah.
Yes, it's PAMS.
Yeah.
So I will add it in the chat as well if useful. But I would, so one thing is really to develop the policies, and of course, there's an effort that should be taken from countries, but policy design should always be evidence-based, and that's why the resources that Jungyu shared on the country practices database and also the manuals to develop the efficiency indicators should be hand in hand with the policy design. I will share the link.
Yes, for any policy, to implement any policies, if it's backed up with data, it's even more powerful. So in the chat box, Yungyu has been sharing information, and now Mafalda has just shared the link to the policy database for Africa. So there are some quite useful material for the participants to learn more on energy efficiency indicators. So if there's no more questions, we will move on to the exercise session. So thanks a lot, Yungyu and Mafalda, for joining for the question and answer. And now let's move to the exercise.
Thanks, our pleasure. Bye-bye.
Thanks, bye.
Bye-bye.
So that was the exercise on energy efficiency. So here you are provided with a table on country A, simplified energy balance, where you have information by fuel and by flows in terajoule net calorific values. And you have a few questions to answer. The first question is, calculate the 2019 energy intensity for country A. And here you are given the GDP for country A in million 2015 dollars PPP, which is $4,258 million. And you're asked to calculate the energy intensity for 2019. So energy intensity, it's calculated as the energy required to produce 1 unit of GDP. So here, to make the calculation, you take your total energy supply here in the cell L9, and you divide it by your GDP, which gives you 5.25. And now you are also provided the information on energy intensity for 2010 here, so 7.8. And the second question is, did energy intensity decrease since 2010? If yes, can you say that this is due to improvement in energy efficiency? So here, yes, you can see that the energy intensity has improved because it's less than the 2010 value. However, we cannot say just by looking at the energy intensity aggregated indicator that this is due to improvement in energy efficiency. So indeed, this decline can be due to an economical shift towards higher share of less energy intensive industries. It could be to services in the economy. But you need additional disaggregated energy and activity data for all sectors and subsectors in order to analyze the energy efficiency. So you really need more information in order to say that this is really due to the improvement in energy efficiency. Just energy intensity indicator is not enough. The question 3 is, now, in addition to the energy balance data, you are provided with some activity data in the table below. So you have production amounts for in iron and steel and cement, and you also have value added information for all those sectors. And the first question is, using the activity data in the table below, calculate the best energy efficiency indicator for each of the 4 industry subsectors here. So for iron and steel and cement, since we have the physical production here, quantities here, the preferred efficiency indicator is to use the physical production in tons. So how much energy is required to produce, for example, 1 ton of steel? So here the preferred unit would be gigajoule per ton. And what we will do here is that we will take the amount of consumption in iron and steel, the total iron and steel value in L15, and you will divide it by the production amount here. Same for cement, you would take your cement consumption, you will divide it by your production. However, for machinery and other manufacturing, as you don't have production here, the preferred we will use instead the value added, which relates to the revenues, and in a certain way it's linked also to the physical production. And in many heterogeneous sector with less quantifiable products, or that carries many different products, example mining, the value added, it's also the preferred option because there is not a single physical product to quantify. So here what we will do is that we will take the machinery consumption, we will divide it by the value added of machinery, and same for other manufacturing here. And here the unit, it's megajoule per 2015 PPP US dollars. Now, if we do the same for industry, iron and cement, it's the same calculation. You take your quantity here, you divide it by your value added. And the last question here, however, when we use value added for efficiency indicators, it brings a certain noise because of the possibility of having different prices. So how much does 1 ton of my product value in a specific market? So when comparing the energy efficiency calculated with value added over different years, it is very important to use constant prices value because in order to remove that inflation noise. The last question is, the table below shows energy efficiency indicators based on value added. Calculate the average annual growth or the total growth for each of the sector, what can you say about efficiency improvement here? So here we are provided with the values for 2010 and 2019 for iron and steel, cement, machinery, and other manufacturing energy intensity. And here we have to calculate the compound average growth rate, which is what is the average growth between the 2 years here, 2010 or 2019. So here what you do is that you take your amount in 2019, you divide it by your amount in 2010, and you put it to the power of 1 over 2019 minus 2010 minus 1, and it gives you a compound average growth rate of minus 2% for iron and steel. For cement, it's plus 2%. For machinery is minus 6%. And for other manufacturing, it's minus 3%. So here we see that all sectors except cement have witnessed a decrease in energy intensity. And this is probably due to efficiency improvement, that is, for example, retrofit of existing plants or the beginning of operation of a new and more efficient plants. So the cement sector, it witnessed an increase in the compound average growth rate. And this could be, again, due to maybe the aging of plants, but also to other factors, such as, for example, the country might be previously importing clinkers, which is the raw material used to produce cement, and is now producing it in the country. So this increased the energy demand for its production. For other manufacturing here, so here without any further specification, it could include many other sectors. So a big shift in structure, that is a change in the supply, in the energy mix, could affect the energy intensity here. So that was the small exercise on energy efficiency indicators. Again, like prices, please take the time to review it. And you can also send me questions by email on this exercise if you have doubts on any of the answers, or if you want some more explanation. So I'm trying to see if there are any other questions. So if you have any questions, you can let me know. Otherwise, we have reached the end of the session. And I hope that this last session on statistics has been helpful to you, and that now you have maybe a more broader picture of the energy statistics and the different indicators and work that you can do with it, and also how useful it can be to your work. And yes, do not hesitate to reach out to us if so I have someone who says, I could not find this exercise in the Excel sheet sent out. This is strange. Normally it's there. But please, if it's not there, please write to me and I will send you the exercise. Are there other participants that did not have this exercise in the Excel file? Let me know in the Q&A box, because it's a bit weird. But happy to resend it to participants in case you have not received it. But normally it's part of the package of the different exercises. Well, if there's no more questions, I wish you all a good day and a good end of Friday, and have a nice weekend too. And I hope that next week, when you start working on modeling, you will enjoy the modeling sessions as well. So bye-bye.